Hello, this is Jishan from JC Tuition, and today we're going to be talking about integration and specifically the method of substitution. So by the end of this tutorial, you will be able to integrate the following. I picked these as I think it encompasses all the skills or little tricks that you could use when it comes to integrating by substitution. By all means, if you've already done integration by substitution, please do have a go at these questions and we'll go through the answers throughout the video. For those of you who aren't familiar with integration by substitution, this is sort of the general method. So firstly, you want to select a substitution, and this is normally in the form of u equals something. The second step is to differentiate that substitution and then write dx in terms of du. So if we have u equals something, it'll be differentiating it, we'll get du by dx, rearranged to get dx as subject to the formula. We can then replace dx by this new term that's involving the du that we just made in step 2. The next step is to replace any obvious terms that could be expressed in terms of u. This will make more sense in a moment, but we're trying to get everything in terms of u. Step 5 is simplify, simplify, and simplify. You want your integral to be as easy as possible with everything sort of in terms of u and maybe a single term if possible. 6, you do the new integral in the same way you would with any other thing that's involving x. And finally, don't forget to write your final answer in terms of x, because of course the initial question will be work out the integral of this, and it'll be in terms of dx, so you need to give your final answer with x. Now this probably doesn't make much sense in terms of words, so let's go through a few questions that will hopefully make it make sense. So the first question to try is this. So we've got two trigonometric terms, and we know that cos is a differential of sine. So I think a good place to start off is select our substitution. So there's no other way to really integrate this. So we want to make it as simple as possible. So let's just say that u equals sine x. Okay, and then remember our next step is to differentiate this. So we say du by dx. Now you should be familiar that sine x differentiated becomes cos x, and then we rearrange to make dx the subject of the formula. Therefore, dx equals 1 over cos x du times du. Okay, so let's rewrite our initial integral. So this is now the integral of sine x, which has been replaced by u, so u to the power of 5, times cos x. Cos x hasn't quite been replaced by anything. The dx has now been replaced by this term, the 1 over cos x du. Now this is quite nice because the cos x's, as you can see, can just cancel out, so we try and simplify all the terms as much as possible. So now we're just left with the integral of u to the power of 5 du. Nice and easy. So now all we got to do is do our normal integration thing where we add 1 to the power, divide by the new power, so u to the power of 6 divided by 6, and remember to add the constant of integration of just c because it's an indefinite integral. And finally, remember our initial question is to find the integral in terms of dx. So we need to give everything back in terms of x. So we just replace the u by the sine again. So final integral therefore is a sixth. The u is going to become sine again. So sine the power of 6x now plus c. Okay, that's our final answer. This is our next integral, and it involves an exponential function. Now you might see questions like this, and how you start off is you make u equal to the terms that have x in it. So we have an x squared here, and we have an x cubed up here. So let's make u the superscript of the exponential. So let's say u equals x cubed plus 4. Okay, so same thing, we differentiate with respect to x. So this becomes bring the power to the front and take 1 away from the power, and the 4 is just a constant, so we don't get a differential for it. So this follows that. We make dx the subject of the formula, that 1 over 3x squared du. Okay, so now let's deal with this thing. So now we've got the integral of, well, x squared is still there. We haven't really replaced that by u yet. We've got e to the power of u. That's what we've made the x cubed plus 4 now. And we need to replace this dx by this term here. So we've got 1 over 3x squared multiplied by du. Hopefully you can see here now that the x squareds cancel out. So we're left with the integral of a third eu to the du. Now this is nice and easy to integrate. You might recall that to integrate an exponential function, especially when it has a single constant of u, it just stays the same. So our final answer is just a third e to the power of u plus c. Well, not our final answer because we need to replace the u by our original term consisting of x. So we've got a third e to the x cubed plus 4 plus c. And that's And that's the final answer for that question. Right, for this one, we use generally what's known as a more complicated term, and in this case the denominator. So let's make u equal to x squared take 6x plus 7. Also, I should note that this question's a bit different to the others because we actually have limits to our integration. So this question is a bit different. So to work out, so we start off doing the same thing. We say du by dx is equal to, well, bring the power to the front, take away 1 away from the power, so that's 2x, take away 6. And the 7 does not become anything as it's just a constant. So then we make dx the subject of the formula. So that's 1 over 2x take 6 multiplied by du. Okay. The next thing is, so remember, even these limits are in terms of x. So we want to make them in terms of u. So when x equals 1, follows that u equals, well, if you put 1 into here, we've got 1 take 6. So that's minus 5 plus 7, so that's just 2. And when x equals 0, well, these two terms are just 0. So it's just u equals 7. So with all of this, let's set up our new integral. So we're working out the integral now between, so the 1 has been replaced by 2, the 0 has been replaced by 7. We've got x take 3 on the numerator still. Nothing's happened to that. The denominator's been changed to u. What else have we got here? Well, we've replaced the dx by this term here. So that's 1 over 2x take 6 times du. So remember, at this stage, you want to try and simplify. Well, I can notice here that 2x take 6 is the same as, if I factorize the 2 out, is the same as x take 3. And of course, x take 3 cancels out with x take 3. So we're just left with 1/2 here. So we've got, I'll rewrite that. So we've got the integral of 2, 7, and we've got 1 over 2u du. So this is pretty simple. This is just the same as 1/2 times 1 over u. And you should be familiar that 1 over u, the integral is a standard one, which is just the natural log of u. So that equals 1/2, because that's just a constant ln. And it's between the limits of 2 and 7. So plugging in 2 into here, we've got 1/2 ln 2. Take away 1/2 ln of 7. There's no need for a plus c here because it's not an indefinite integral. We've got boundaries. So factoring out 1/2 here, we've got 1/2 ln 2 take ln of 7. And that equals 1/2. And using our natural log rules, when you take away two logs, you just divide one number over the other. So it's just 2 over 7. Should be familiar with that. And that's the final answer for that. So some questions you might be asked, well, you might be told what u is. So in this case, we've been told that u is 4x take 1. Therefore, we're going to have to use that. Okay, so if u equals 4x take 1, well, du by dx is simply just 4, right? And the negative 1 is just a constant, so it doesn't get differentiated. So that follows that, therefore, dx equals 1/4 du. All right, so just rearrangement. So let's just try and plug some stuff in here. So what we're left with then is, so this integral here, we're left with the integral of, well, the x is still there, we haven't really done anything to that. The square root of u, because we replaced 4x take 1 by u, and we'll replace dx by this term here, so that's 1/4 du. Okay, well, there's not, this x doesn't cancel out like it sort of did in the last question, so that's kind of annoying. Let's try and get rid of it another way. But we know that u is 4x take 1. What if we make x a subject to the formula and then replace it? So if u equals 4x take 1, well then we add 1 to both sides. We've got u plus 1, and then divide everything by 4, and that equals x. So now we can replace this term by the x here. So I'll show you what we mean. We've got the integral of u plus 1 over 4 times square root of u. It's easier to do integrals with indices, so we're going to times multiplied by u to the power of 1/2 and multiplied by 1/4 du. Well, we've got 1/4 and 1/4 here, so we can take that out because it's just a constant. So that we've got 1 over 16, the integral of u plus 1 times u to the 1/2 du. So what does that equal? So we've got u times u to the 1/2. So imagine that's u to the power of 1. We just add the indices together when you're multiplying the indices together. So we've got u to the power, so integral is 1 over 16, the integral of u to the 3 over 2, and 1 times u to the power of 1/2, that's plus u to the 1/2 du. So what does that equal? Well, that equals, so we've got 1 over 16, and then we've got u factor to the power of 3 over 2, that's quite easy. You add 1 to the power divided by the new power, so we've got, add 1 to the power is 5 over 2 divided by the new power, is divided by 5/2, so or that's the same as multiplying by 2/5, isn't it? Add u to the power of a half, so add 1 to the power, we've got 3/2, divide by 3/2, well that's the same as timesing by 2/3, and don't forget to add c. Well, these 2's cancel out with this 16, just left with an 8. And simply now we just need to replace the u's with our initial 4x take 1, and we've got our final answer. Don't need to really simplify it anymore. So we've got, therefore, we've got 4x take 1 to the power of 5/2, all divided by 5, plus 4x take 1 to the power of 3/2 divided by 3 plus c. And that's our final answer. So hopefully you can see why substitution is so important, because the final integral is so messy. So the final question, we're being told something a bit different. We're being told that x equals u squared rather than u equals something. And you can get questions like this, so I thought it would be worth going through. So we start off, but instead of doing du by dx, we're going to have to do dx by du. So let's do that. So dx by du, well, you bring the power to the front, minus 1 for the new power. So you guys know the deal. We're left with 2u. So it follows that dx, therefore, is, well, we multiply both sides by du, we're just left with 2u du. Okay, what else? Well, let's say we've got definite intervals here. So we've got where we've got x equals 25 and x equals 9. We need to convert those to u. So when x equals 25, well, that means that u squared also equals 25. So therefore, u equals the square root of 25, which is just 5. Remember, u is greater than 0. And what about when x equals 9? Well, u squared also equals 9. So it follows that u equals 3, again, because u, we know, is a positive number. So let's see what we've got so far. We've got the integral between the 25 has been replaced by 5, and 9 has been replaced by 3, and we've got 1 over x, but x we know is u squared, minus 2 root x. But the root x, I mean, if we just look at this again, if x equals u squared, well, if we square root both sides, we've got that u equals the square root of x. So we can actually replace the root x here by u as well, so that's 2u. And then the dx is replaced by this term here, the 2u du. Okay. So remember, the next step is we always want to simplify. So let's rewrite this in a way. We've got 5, we've got 3. Let's put 2u in the numerator, divided by, let's factor out a u from the denominator. So we've got, therefore, u take 2 times du. And as you can see here, these u's very nicely cancel out. So we're just integrating 2 over u take 2, which 2 is just a constant, and 1 over u take 2 we should know is a standard integral for ln of the natural log u take 2. Don't need to say plus c because we've got definite integrals here which we need to just work out. So we've got 5 and 3. So plugging 5 in, we've got 2 ln, if u equals 5, 5 take 2 is 3, take away 2 ln, if u equals 3, 3 take 2 is 1, ln 1. And you should be familiar that the natural log of 1 is just 0, so this term just becomes 0. So we're left with 2 ln 3, which is, using the power log rules, we got ln 3 squared, which is just ln 9. So again, substitution allows us to take this crazy integral and just leave us with a very simple answer. So very useful. And that's all the integrals. So I hope it all makes sense. I'll just leave you here with the general method of what we do. If you would like more tutorials, please visit www.jctuition.net. And yeah, thank you for watching.